Okay, we have a series of a few mini lessons on just reviewing how to factor. And so we're going to start with the most basic type of factoring, and that's factoring a greatest common factor out of a polynomial. Okay, so when you're looking to do that, which is always the first thing you should do if you're given a polynomial expression that you want to factor, you're going to first look at the coefficients in front of each term, and you're going to see if you can come up with a factor or a value that is divisible into both of those things or all of those things. In this case, we can see easily that 3 divides into both 3 and -6. Then you also want to look at your variables, okay? And you want to think, what is the greatest power of this variable that I can divide out of both pieces or all the pieces? And of course, in this case, it would be x. Okay, once you've identified your GCF, you're going to open up a set of parentheses. All right, open up a set of parentheses here. And what's going to go inside that set of parentheses is the result when we divide out that GCF. So let's divide out the 3x from both of those pieces. We got 3x cubed divided by 3x. That's going to give us x squared. We've got -6x divided by 3x. That's going to give us -2. And that would be our solution. That would be our factored form of this expression. Okay, let's look at the next one. Let's start by looking at the coefficients. All right, and let's think to ourselves, what would be the largest possible value that divides into all of those values, 5, -20, and 45? Hopefully you were able to identify that as 5. Now let's look at all of the variables. Variables here. Oh, there isn't one here. And so a variable will not be part of our GCF because there isn't a variable in every single term. Okay, so 5 is the only thing that is our GCF in this case. So let's go ahead and divide it out of every term. All right, so when we're looking at this first thing, 5x cubed divided by 5 is going to give us x cubed. -20x divided by 5 is going to be -4x. And +45 divided by 5 is going to be +9. Beautiful. Okay, in this next example, we have something that's a little extra. It's a little bit different than what we're used to seeing as a greatest common factor, because usually we see monomials as our GCF. However, what we see here is two groups, and they both have a common factor. Do you see it? It's a little bit different. Okay, but that is our common factor. It's a binomial this time. It's 2x minus 1. We're going to do the same thing, and we're going to divide out 2x minus 1 in both of these groups. And do you see what happens? We end up with x minus 7 as our second binomial. Excellent. All right, and then in the last example here, we're going to have a GCF that's a little bit more. It's a monomial, but it's a little bit more than what we've seen so far. Okay, so let's start with our coefficients. We've got 20, -8, and 4. All right, that looks like a GCF of 4 as part of our GCF. That looks like 4 is going to be part of our GCF. Now let's look at each variable individually. A cubed, a to the 6th, and a squared. What's the largest power of a that I can divide out of all the terms? That's going to be a squared. And then let's look at the last bit, b to the 4th, b cubed, and b. What is the greatest power of b that divides out of all of them? That's just going to be b. All right. So now let's go ahead and divide each of those terms by what we've identified as our GCF for a squared b. All right, and open up that set of parentheses. So notice that we have, when we divide this 20a cubed b to the 4th by 4a squared b, we have 5a b cubed. All right. In the second term, we've got 8a to the 6th b cubed divided by 4a squared b. We're going to get negative 2a to the 4th b squared. And the last thing, we've got 4a squared b divided by 4a squared b. That's going to give us just a plus 1. And those are good ways to get you started in factoring a GCF. Sometimes that's all you can do, and other times it's just the first thing you do when you have it in conjunction with other things. See you next time.